Okay, let's figure out this question. This they are asking the number of onto functions or surjective functions from set x to y. So they have given a particular set x and they have given another particular set y. They are talking about onto functions from x to y. So that set 1, the set first set x is having 1 2 3 4. The second set y is having the elements a b c, and number of onto functions means all the three should be mapped, means every element in y should have at least one pre-image in x. So if let's say everything is mapped, everything in x is mapped to either b or c, and one has no pre-image, then that is not onto function. But they're asking about number of onto functions. Okay, so you might have read it. So the number of the counting onto functions is done by something which is popularly known as the principle of mutual inclusion and exclusion. So that we are going to use it here, but rather than simply using the formula, we will try to intuitively understand that how that mutual inclusion exclusion works and why that is used in this particular scenario. Okay, in order to do that, firstly we will try to approach like that firstly let's count the total number of functions. Okay, leave onto functions, just what are the total number of functions from x to y, that is number of elements in y raised to the power number of elements in x. So 3 raised to the power 4. So 3 raised to the power 4. Okay, and again try to intuitively understand why this 3 raised to the power 4. So this will have an image definitely, because in function every element in x should have an image. Now how many ways this can have an image? It can have image to a, it can have image to b, it can have image to c. So there are 3 ways this a can one first number 1 can be mapped. Similarly 3 ways 2 can be mapped. 3 ways 3 ways. So total number of ways will be 3 into 3 into 3 into 3, that is 3 raised to the power 4. And what is that? This is the total number of functions. Okay, I'll just write functions, but these are functions from set x to y. Now let's talk about the number of functions, where at least one element don't have a pre-image. So at least one element, so let's say b or a does not have a pre-image. So when we are talking about that at least one element does not have pre-image, then we can do something like this, that okay, why can't we choose out of y the one element, at least one element which is not going to have a pre-image. So at least one element, so we are going to select one element. So let's say in 3c1 ways I have selected a particular element, that okay, this a is selected, this is not going to have pre-image, so everything in x is going to be mapped to either b or c. And how many ways that can be done? Again, this has two options, this has two options, so basically 2 into 2 into 2 into 2, so basically 2 raised to the power 4, right? So 2 raised to the power 4, 3c1 into 2 raised to the power 4, it is the number of ways in which 3c1 into 2 raised to the power 4, it is the number of functions in which at least one element don't have pre-image. Now I have selected exactly one. Why I am talking about at least one? Because see, once I have said that this thing does not have a pre-image, and after that everything has to be mapped to either b or either c, then there can be a scenario when everything is mapped to only b. See, it has two choices, b or c. Let's say I have chosen b only. It has also two choices, b or c. I have chosen b only. So in that case, everything can be mapped to b, or everything can be mapped to c. So there are situations where not only one but more than one element don't have a pre-image, right? So that's why I have called at least one element. So 3 raised to the power 4 is the number of functions, and then we subtract from that the number of functions which where at least one element don't have a pre-image. Now this looks fine, but the problem is that we are basically subtracting more. We are over counting this thing, and we are subtracting more here. Why? I'll give you an example. Let's say you have selected in 3C1 ways. First time you have selected A, and then everything is mapped to B or C, and let's say you are getting an option where everything is mapped to C. Everything is mapped to C. Okay, then you are getting a situation where everything is mapped to C and A and B are having no pre-image. That is in one of the ways when A is selected. Now my point is that it can happen that, let's say, we are now going to, in 3C1 ways, now we are going to select B, that B is not going to have any pre-image. So everything has to be mapped to either A or C. And in order to do the mapping from A, from this to A to C, let's say there is one way, obviously there will be one way where everything is mapped to C. So again everything is mapped to C, and then there is no mapping of pre-image of A and B. So again the same thing, what we selected from A, that condition is again coming in here. So basically what is happening, everything is counted twice, right? So more than, not only twice, it depends on the counting. So basically we are doing more over counting. The same situation is happening more than one number of times. How can we solve that? We can solve that by adding in it the number of ways in which two elements don't have a pre-image. So what are the situations where that was coming? So these two things, when A was selected, then also this case came, and B also selected, then also this case came. So that thing is counted over. If we can somehow add those number of ways, that okay, so number of functions in which two elements don't have pre-image. So in that case I am going to select in 3C1 ways. I will select one element, let's say one element. So 3C2 basically, 3C2 and 3C1 is basically same, but still 3C1 I have taken here, for which we are not going to have an image. So in that pattern only, let's take 3C2, the elements which are not going to have a pre-image. So let's say I have selected A and B, then A and B are not going to have a pre-image, and everything will be mapped to C. Similarly in 3C2 ways, another way can be B. So B, another way can be let's say B and C. In that case B and C are not going to have a pre-image, and everything will be mapped to A. Okay, so in that case we can understand that 3C2 into 1 raised to the power 4, everything will be mapped to 1, that thing will be there. This is the total number of ways, and that has to be added because that was overly subtracted from here, and that is how you're understanding how the the principle of mutual inclusion and exclusion is working, that alternating subtraction and addition is happening in that fashion. Now we cannot go any further because we have reached 1. So our final answer is going to be this, whatever the number of onto functions, that is this, and that is essentially 3 raised to the power 4, which is what, 81. Okay, and minus, and then it is 16 and 3, it is 48, and then it is 3 into 1, which is 3, right? And 81 and minus 45, which is 36. Okay, so 36 is the total number of onto functions from x to y in this particular situation. Okay, 36 is the answer.